Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about projection of points. I am Dr. IPS Ahuja, Professor, Mechanical Engineering Department, Punjabi University, Patiala. So a point represents a location in the space and it is a dimensionless entity which has simply position but no magnitude. So it is usually represented by a dot or a very small circle. Now since point doesn't have any magnitude but simply it has got the position, so the projections of the point, they don't have any practical significance, but it serves as the basis for projections of lines, projections of planes and projections of solids. Now the distance of a point from the horizontal plane and the vertical plane, they are required to determine its position in the space. So this we have already discussed, that whenever a point lies above horizontal plane and in front of the vertical plane, it will fall in the quadrant number 1. If a point falls above HP and it falls behind VP, then the point will lie in quadrant number 2. If a point lies below horizontal plane and behind the vertical plane, the point will be lying in quadrant number 3. And similarly, if the point lies below HP and in front of VP, then the point will lie in quadrant number 4. So once we know the coordinates of the point, that is the distances of the point from the horizontal plane and the vertical plane, obviously we can work out in which quadrant does the point lie. Now here you see we can work out different orientations in which point can lie. So in this figure we can see that point A or 1, it lies in the first quadrant because it lies above HP and in front of the VP. So this is the 2D representation. Then the second case we are going to discuss is the coordinates of point B, which lies behind the vertical plane and above the horizontal plane. So this point happens to lie in quadrant number 2. Then the third location of the point in the space is in quadrant number 3, in which the point lies below the horizontal plane and it lies behind the vertical plane. And the fourth location of the point in space we are going to study is point D, which lies below the horizontal plane and in front of the vertical plane. And besides these 4 locations, then another 5 locations of the point in the space we are going to study, that is point 5 or point E, which lies in the horizontal plane and in front of the vertical plane. Point F or 6, it lies in the horizontal plane but it lies behind the vertical plane. Then the 7th point, that is point G, it lies in the vertical plane and it lies above the horizontal plane. Then point H or point 8, it lies in the vertical plane but it lies below the horizontal plane. And finally we have the final location, that is point I or point 9, it lies in both horizontal plane as well as the vertical plane. Now we are going to discuss about how do we draw the projections of all these points when the distances from the HP and VP, they are known to us. So these were the different points which we have already discussed. So these are the locations of the point which we are going to discuss in a little bit of time. So here you can see earlier one we had shown the 2D representation of the location of all these coordinates of the points. Now here we have the 3D representation. So in the 3D representation also you can once again see point A lies in the first quadrant, that is above HP and in front of VP. Point B, it lies in the second quadrant, that is behind VP and it lies above HP. Point C lies in the third quadrant because it lies below the horizontal plane and behind the vertical plane. And point D, this point D lies in the quadrant number 4 because it lies below the horizontal plane and in front of the vertical plane. Similarly, you have point E which lies in the horizontal plane but it lies in front of the vertical plane. Point F, it lies in the horizontal plane and it lies behind my vertical plane. Then you have point G which lies in the vertical plane but it lies above the horizontal plane. Then you have the point H which once again lies in the vertical plane but it lies below the horizontal plane. And finally you have the point I which lies in both HP and VP. Now one by one we are going to pick up each one of these cases and find out how do we draw the projections of all these points when they are at different locations from horizontal plane and vertical plane. Now we'll start with all these examples. So earlier on we did not get the distances. Now we have marked the distances of all these points from the horizontal plane and the vertical plane, and one by one we'll be picking up each case and we'll draw the front view as well as the top view of the point. But before we start drawing with that, we need to know about the notations. So the notations are just like this, that the front view of a point shall be indicated by A dash, B dash, C dash. That is all the small alphabets we are going to use to represent the front view, followed by the dash. So whenever in any given engineering drawing you are given that the point's name is either A dash or B dash or C dash for that matter, so we will automatically understand that we are talking about the front view of the point. Similarly, whenever in any given engineering drawing we are given that point's name is small a, small b or small c only, we will understand that this point we are talking about the top view of the point. So the top view of the point shall be indicated by small alphabets A, B, C and so on. And whenever we are talking about the side view, then the side view of a point shall be indicated by A double dash, B double dash and C double dash. So let us start with the projections of the point A which was lying in the first quadrant. So to begin with, we are going to see how we can go about representing this point onto the 3D plane. So these are the 4 quadrants. As we already know, this is the quadrant number 1, this is quadrant number 2, this is quadrant number 3 and this is my 4th quadrant. So these are all the 4 quadrants. So here you have the horizontal plane, this is your vertical plane. So whatever image is obtained on the vertical plane will stay in its position, that will be our front view. Whatever image of the object or the view will be obtained on the horizontal plane, it will be called top view. But both of these front and top views, they are obtained in the mutually perpendicular planes. So this portion of the horizontal plane has to be rotated downwards, and this portion of the horizontal plane which lies behind the VP, so this will be rotated upwards so that we can get both the front views as well as the top views onto the same plane or onto our screen of the computer. So let us draw the first of all the coordinates of the point A. So you see here we are given the position of the point A, and what are the coordinates? The coordinates are, this point A lies 35 mm above the horizontal plane. So we have to pick up this distance from the horizontal plane as 35 mm, and the distance of this point from the vertical plane is given to us as 20 millimeter. So here you see I've drawn 20 millimeter from the vertical plane and 35 millimeter from the horizontal plane. So these two coordinates, that is positive coordinate above HP and positive coordinate that is in front of VP, though these two coordinates, they are going to define the location of the point in the space. And since H and D both are positive, so this point happens to lie in the quadrant number 1. Now let us draw the front view of this particular point whose position in the space is shown over here. So if we are looking from the front side, you see the observer is there in the front view. So observer is lying here in the first quadrant. What is happening? My object lies between observer and the plane of the projection. Once the observer is looking from this side, the rays of sight or the projector lines will be falling upon this, and then the image or the view or the projection of this point will be appearing on the vertical plane in the form of the front view. So here you can see the image of this point will be formed on the vertical plane in the form of my front view, and this point's name is called A dash. As I told you earlier, the front view will be denoted by the term A dash. And another thing we need to remember, that front view will always be obtained on the vertical plane. So my front view lies now 35 mm above the horizontal plane. This is what I will be drawing once I draw the projections. But now let us look at this object from the top. So what is this object? This object is a point. Once I am looking at this object or my point from the top, now the rays of sight will be falling upon this, and the projection of this will be obtained on the horizontal plane, or the image of this point will be obtained on the horizontal plane. Just see, this is my projector line, and wherever it intersects the horizontal plane, I get the coordinate of my point A. And what is this point A? Point A happens to be the top view of the projection of this point, capital A. So this is called top view. So I have drawn the front view, which is 35 mm above HP. I have drawn the top view. How much is this in front of VP? 20 mm. I've already shown it over here. So this distance happens to be 20 mm, and this distance happens to be 35 mm. So let us join these coordinates. So once we join this, now we know that there is definite relationship between A dash and A. And what is this relationship? This relationship says that A dash, that is the front view of the point, will lie directly above the top view of the point, that is small capital A. So once I fold this horizontal plane downwards, just see, once I fold this horizontal plane downwards, A dash and A point, they will be lying in one vertical line. So A dash, that is the front view, will lie 35 mm above this XY reference line, whereas the top view will be lying 20 mm below the XY line, just vertically below the point A dash. So let us draw the projections of these 2 points. So front view will stay in its position as it is. What is? As it is 35 mm above my reference line, which is XY. And this is, you see, 35 mm above my reference line. And what is this distance? This distance is 20 mm. So this distance happens to be 20 mm, and we need to remember the front view will be obtained on the vertical plane and the top view will be obtained on the horizontal plane, and both the projections of the point, they will be falling in one vertical line over here. So now we do the dimensioning over there. That is A dash point, that is front view, will lie 35 mm above the horizontal plane, that is above the XY line, whereas the top view lies 20 mm below the XY line. So this validates the fact that in the first quadrant, my front view always lie above my top view, and the front view lies above the XY line, and the top view of the point or the object, it lies below the XY line. So distances we know, so we have drawn these distances over here. So the front view is above XY and the top view is below XY. So these are the projections of the point A, and this point happens to lie in quadrant number 1. Next, we pick up the coordinate position of the point B, and we'll find out where does this lie. So point B is 35 mm above HP. So we'll draw one line over here, which is 35 mm above HP. So we'll mark 35 mm over here and draw one horizontal line. Then it is 25 mm behind VP. So we'll measure from here 25 mm. So let us say this is the distance. So this distance we pick up and then draw the vertical line. So the vertical line will be the distance. It will give us the distance above HP, and this line, horizontal line, will give us the distance of the point behind VP. So by looking at the coordinates, we fully understand that this particular point or the object lies above HP and behind VP. So this happens to lie in quadrant number 2, that is the second quadrant. So let us draw the location. So looking at the coordinates, after measuring the distances, we have worked out that B point happens to lie in quadrant number 2. Now we have marked the distances. So the behind distance is 25 mm and above HP distance is 35 mm. So I have got to know the position of the point in the space. Thereafter, the next thing I want to do is I want to draw the projections of this point B, and I am looking from the front once again. And as we have already discussed, now we are going to treat this plane as transparent. Earlier in quadrant 1, we have treated both these planes as opaque. Now here in the front view, we will treat the vertical plane as transparent. Once the observer is looking at this point, its projection will be projected onto the vertical plane like this. So rays of sight will go and then again it will fall upon this my plane of projection, which is the vertical plane. So here you see the projection of this point will be obtained on the vertical plane since we are looking from the front. So the position we'll call as this point's position we will call as B dash, and the moment we say it is B dash, we understand that this is going to be the front view of the object or the front view of this point B. Then next we are now looking at same point or the object from the top. Now while we are looking at this object from the top, this plane we are assuming to be an opaque plane so that we can obtain the image of this point onto this plane over here. So once the observer is looking at this point from the top, now you see the projection will be appearing on the horizontal plane, and wherever this rays of projection or rays of sight they intersect with the horizontal plane, this point will be called small b. Just see, this point is small b. And what is the location of this point? This will be 25 mm behind VP. What is the distance of this point? This will be 35 mm above HP. So having located this point B, now B stands for the top view. So top view is obtained on the horizontal plane, front view is obtained on the vertical plane. So I have marked the top view over here. Now let us join these two projections, that is the front view and the top view projections. So this way you see we have joined both of these. But now you need to understand that we have obtained front view on the vertical plane and the top view on the horizontal plane, but both of these projections they are lying in the mutually perpendicular planes, and we have already discussed that the horizontal plane behind VP will be rotated upwards. Now this projection we have to rotate upward. How will do it? We'll keep our compass over here, our pen needle of the pencil will lie here, we'll rotate it upwards. So just see, this point B will fall somewhere here. So there will be overlapping of these two projections above the horizontal XY line. So we are going to draw, you see the XY line. So this is my vertical plane, this is my horizontal plane, and once I rotate this point B, so point B will be located 25 mm above the XY line. That is, both these projections now they are available above the XY line. Why? Because the front view was already above the XY line at a distance of 35 millimeter. Now this distance was 25 millimeter as we have indicated over here, and once we rotate this HP clockwise, this point B will be appearing over here. So that this is how we have obtained the location coordinate of this point B. Now had the distances been equal, so B and B dash would have overlapped over there. And let us say if we inverse these two distances, let us say we assume that the point happened to be 35 mm behind VP and 25 mm above HP, then these 2 points they would have also reversed over here, because this distance would have become 25, so this would have stayed over there, this distance would have become 35, so B dash would have come, B would have come above the B dash. So these two could have been in the reverse order had you got the distances swapped over here. If the distances would have been equal, these 2 points they would have overlapped. But in this case, the front view happens to lie 35 mm above the XY line, and the top view, because it was 25 mm behind VP, and once you rotate it upwards, so this lies 25 mm above the XY line. So here the crux of the situation is that both the projections will be obtained above the xy line. So only thing is the distances will help us to indicate whether they overlap, whether the front view is above the top view or the top view happens to lie above the front view. So both of these views, they will happen to lie above the xy line. So these are the coordinates for a point or an object which is lying in quadrant number 2nd. Now we are going to start with projections of the point which is lying in the 3rd quadrant. So here you can see we have shown the HP, VP and all the quadrants. Now point C, it happens to lie 30 mm below the horizontal plane. So you see we are going to mark a line 30 mm below the horizontal plane, and second coordinate is 25 mm behind VP. So we'll go 25 mm behind VP. So 25 mm behind VP and 30 mm below HP. So once you join both of these, the one horizontal and one vertical, you will get the location of this point C in quadrant number 3, because we understand that whenever a point happens to lie below HP and behind VP, the location is in quadrant number 3. So in quadrant number 3 we know the distances. Let us mark those distances. So the distance behind VP and below HP, they are indicated over here. 30 mm below HP, 25 mm, this is behind VP. So once we know these distances, we get to freeze the location of this point in the space. Now once again, as usual, we are going to look at this object from the front. So while we are looking at this object from the front, this vertical plane or the plane of the projection will be treated to be transparent. Similarly, once we are looking at the object from the top, again the horizontal plane will be treated as the transparent plane, so that we obtain the projection of this point onto this plane. So let us look at this object from the front. Now this image of the point C will be appearing on the vertical plane. As we are looking from the front, so the name of this point will be C dash. And what is the location of this? 30 mm below my horizontal plane. So this is 30 mm below my horizontal plane. Similarly, now I am going to look at this object from the top. Once I look at this object from the top, this point will be projected onto the horizontal plane at this particular position. Since I am looking from the top, the name of this point will be small c. Top view is represented by small alphabet and we mark it as a top view. Now you see we have obtained front view over here on the vertical plane which is below the xy line, but the top view we have obtained on the horizontal plane. So both these points, they are falling, or the projections, they are falling in the mutually perpendicular plane. I want to draw it onto a 2D plane or a computer screen. So what I'll have to do, again this rotation of the HP has to follow. Once I rotate this, just see, I'll keep my compass the needle over here, open compass 25 millimeter, and then rotate it onto the vertical plane over this position. So my top view will lie now 25 mm above the xy line, whereas my front view will lie 30 mm below the xy line. So let us draw these projections over here, and once again you see we have joined these projections with this line, indicating that C and C dash, they will be both lying in one vertical line. So let us draw, this is my xy line, this is my vertical plane onto which, just see, the top view has been obtained. This is my front view where the front view, that is C dash, has been located. So C has been located, C dash has been located. The distances as they were indicated have been mentioned in this particular projection. Now C lies above xy line and C dash lies below the xy line. So this is what we have already discussed, that in quadrant number 3, the front view of the object or the point will lie below the xy line and the top view will lie above the xy line. And these are the projections of the point which happens to lie in quadrant number 3. Similarly, let us start with projections of the point in quadrant Number 4, so there is point D. So please see, point D lies 35 mm below my horizontal plane. This is my HP. It lies 35 mm below my horizontal plane, and its distance from VP is 25 mm in front. So 25 mm in front and 35 mm below. 25 mm in front, 35 mm below. So let us freeze the location of the point in the space. So here you can see we know the distances from HP and VP. So we know the distance 25 mm in front of VP, 35 mm below the horizontal plane. So we have checked the location of the point D in space. Now we are looking from the front. The observer is looking from the front. VP will be treated to be an opaque plane. So the projection of this point D will appear onto my vertical plane in the front view. So this point I am going to call as D dash. And how much will be the distance? Distance will be 35 mm below my horizontal plane. So let us do that. So please check. So this is my projection line, rays of sight or rays of light. So as it falls and meet your vertical plane, the projection of this point will be obtained on the vertical plane. This, since we are looking from the front, the name of this point is D dash, and we have obtained the front view of this particular point. Now we are going to look from the top. Once you look at this object from the top, what will happen? This plane we have to assume as transparent plane so that we can obtain the image of this point over here. So let us do that. The projection of this as it intersects with the horizontal plane will be obtained here. And since we are looking from the top, this projection name will be called small d. So this is called the top view of the point. And then we need to join both of them with a straight line over here. Now what is the location of this? This is 25 mm in front of my vertical plane. This is 35 mm below my horizontal plane. And since the front view and the top view, they have been obtained in the mutually perpendicular planes, so I want to draw them on a single 2D plane, two-dimensional plane. So I have to rotate my horizontal plane, which is in front of the vertical plane over here, in clockwise direction. So clockwise means I have to turn it down. How do I turn it down? I'll keep my needle over here, needle of the compass, open compass this much, rotate it in the downward direction. So how much is this distance? This distance happens to be 25 millimeter. So since the distance of the point from the VP is lesser, so this point will be located over here. Had you got the distances reversed, D would have appeared here and D dash would have appeared here. But if the distances were equal, both these points, they would have overlapped. So let us draw the projections of this. So as we have seen, distance of D, this is 20 mm, 25 mm in front of VP. So this distance we have to draw as 25 mm, and since this distance happens to be 35 mm, so D dash will appear at a distance of 35. And this is not a standard. If the distances they are reversed, D will appear here and D dash will appear here. So there can be change in locations of this point, and if the distances are both equal, both these points they would have overlapped. So rather than seeing two projections, we would have seen only one projection, and I would have marked D and D dash straight away over here. So in this situation, in the present situation, my projections, they have been drawn below the XY line. Whatever happens, whether the distances from HP or VP, they are same, they are different, but both these projections, they will be drawn below my XY reference line. So this is the projection of the point D, which was lying in my quadrant number 4. So this is the fourth case. Now let us pick up case number 5. Now once again we are going to locate the point in the space. So these are our 4 quadrants. Now this is a point E, which is lying in the horizontal plane, and it is 25 mm in front of VP. So just check it out. This is a point which is lying in the horizontal plane, and it is 25 mm in front of VP. So once my point is located, I find out that my point E it lies on HP and it is at a distance of 25 mm from my vertical plane. So once I look at this, now I need to work out, first of all, in which quadrant this particular point lies. This point E happens to lie in quadrant number 1 as well as in quadrant number 4, because it is lying on HP. Anything lying on HP, if it is lying in front of VP, it will lie in quadrant 1 and 4. If it is lying behind VP, it will lie in quadrant 2nd and 3rd. So since in this case the point is lying in front of VP, so this is lying in quadrant number 1 and quadrant number 4. Now let us look at this point. Let us draw the projections. Once the observer is looking at this point from the front, what is happening? This point, since it is located on HP, its projection will be, front view will be obtained on HP. On HP means on the horizontal reference line. So whatever this XY reference line is there, because this point was lying on HP, so on HP means on XY reference line. So I obtain the E dash point, that is the front view on the XY line. Now let us draw the projection of this point as the observer is looking from the top. As the observer is looking from the top, the rays of sight will be falling over here, and again this point's projection will lie right away at this particular location on the HP. So this distance of 25 mm will give me the location of this coordinate, that is small e, which is my top view. Now this projection is lying over here, but this is lying on HP, that is the top view is lying on HP. So front view lies on XY line, but the top view is lying on HP. But projections on HP cannot be viewed directly. So what we have to do, once again, rotate this downwards. So keep the needle of the compass here, keep your pencil here, rotate it downwards. And how much? 25 mm is to be the radius of this. So you need to draw this vertically over here, 25 millimeter. So front view will lie on the XY line, whereas the top view will lie 25 millimeter below my front view. So please check this out. This is my vertical plane, this is my horizontal plane. Here I get my XY line. So front view, since the point was lying on HP, front view lies on the XY line, and my top view will lie 25 mm below my front view. So this is a situation where a point is lying in quadrant 1st and quadrant 4. So these are the projections of the point E, which was lying on HP and in front of VP. Next we pick up the point F, which is lying on HP, but it is lying behind VP. So it is lying behind VP. How much? 20 mm behind VP. So this distance happens to be 20 mm behind VP. So we locate the coordinates of this point F. So since this point is once again lying on HP, so its distance from HP is 0. So since its distance from HP is 0, so this point will happen to lie in both quadrants, second and third one over here. And since it is lying behind VP, so we can now once again try to draw the front view. So please check. Once we look at this object from the front, or the point from the front, its projection will appear on the XY line, because the distance from HP happens to be 0. So at a 0 distance from reference line, that is on XY reference line, the front view will be obtained. So just see, front view we have obtained. And similarly, now we look at this object from the top. The moment you look at this object from the top, the rays of sight will fall over here, and wherever they intersect with HP will give me the top view. So since point happens to lie on HP, so the top view will coincide with the physical location of the point. And then this is the mutually perpendicular plane. So the back of the horizontal plane, backside behind VP, has to be rotated upwards. So again, keep the needle of the compass here, pencil over here, rotate it upwards by how much? 20 millimeter. So for this point, my front view will appear on the XY line, and my top view will appear 20 millimeter above the XY line. So you can check, this is my vertical plane, horizontal plane, the front view will appear on the XY reference line, and my top view will be rotated and it will appear 20 mm above my XY reference line. So these are the projections, and the point happens to lie in quadrant number second and third over here. Now after point F, now if we pick up the projections of the point G, so point G happens to lie in the vertical plane and it lies 15 millimeter above HP. So if the point lies in VP, it can lie over here, it can lie over here, but in this case it is lying 15 mm above the horizontal plane. So 15 mm above, we mark the location of this point. So this is my point G, and if I look at this point from the front, so I'll obtain the projection of this point G right over here. And if I look at this point from the top, this projection, that is the top view, will be obtained here. So let us see. If I look at this point from the front, so the front view projection line will be, projector will be falling upon this. So obviously wherever it meets VP, it is going to give me the front view. So it will be coinciding with the physical location of the point. So this is my front view. When I look at this object from the top, so this point will be projected downwards because it is lying in VP. The top projector will be falling upon the XY line. So it does not have any distance from the vertical plane, either forward or backward. So it will lie on the XY line. So this is going to give me the top view of this particular point. So front view lies 15 mm above the XY line. The top view lies on the XY line. And in which quadrant does this point lie? Because it lies in VP. So this will lie in quadrant number first as well as in quadrant number second. So let's draw the projections of this point. Top view lies on XY line, whereas the front view lies 15 mm above my XY line. So this point happens to lie in quadrants 1 and quadrant 2. So then next we move on to the projections of the point H, which is 15 mm below HP and it lies in VP. So just see, this lies in VP, but it lies 15 mm below my vertical plane. So below my horizontal plane. So now let us locate this point. Let us work out the physical location. So this is my physical location of the point. 15 mm below the horizontal plane and it lies on the vertical plane. So let us look at this point from the front. So once we look at this point from the front, my projector line will be falling upon this. So the front view will coincide with the physical location of the point. So I get the front view as H dash. Now next we move on to the top view. The observer is looking from the top. Once the observer is looking from the top, the projection of this point H will appear on my XY line. Why? Because there is no distance from HP, zero distance. It is contained by the vertical plane. So anything which is contained by vertical plane will be projected on the XY reference line. So the top view, you can see it will be located on the XY line and the name is small h. And this is my top view. So I know the front view, that is 15 mm, it is lying below the XY line and the top view is lying here. And in which quadrant does it lie? This point lies in quadrant number 3 as well as quadrant number 4. And let us draw these projections. H dash is 15 mm, that is front view, below the XY line, and point H, it lies on the XY reference line. And the quadrants, they are third and fourth quadrant. Next we have point I, which lies on both HP and VP. So anything which lies on HP will lie here, anything which lies on VP will lie here. So since this point I lies in HP and VP, so it lies at zero distance from HP and zero distance from VP. So if a point lies in HP, distance from HP is 0. If a point lies in VP, the distance from VP is 0. So since this point lies in both HP and VP, the distance is 0 from both HP and VP. So point I lies on the XY line. So whether you look at this point from the front, you get the front view on XY line, and whether you look at this point from the top, you get once again the top view of this point located again on the XY line. So all the two projections and the original point, they will all coincide with each other. And in which quadrant does this point lie? Because it lies on HP and VP, it will lie in all the four quadrants. So just see, you have point over there on the XY line, the projections, the front view and the top view, both of them, they will lie and they will on XY and they will both coincide. And quadrants, they are first, second, third and fourth. So this way you see, we have understood that how all these points, all these 9 cases we have discussed, how the location of the point will vary depending upon its distance from HP and VP. Now we are going to draw all these cases onto the drawing sheet, because now we have understood all these cases individually and independently. So one by one we are going to show it onto the drawing sheet how we can draw it. So first point, 35 mm above HP and 20 mm in front of VP. So this is the projection that we are going to draw for point A. And in which quadrant does it lie? Quadrant number 1. Leave 30 mm from this projection line. 30 mm from this, draw the projections of the point B. So for every point projection we are going to leave 30 mm distance from the previous one. So now point B, it lies in the second quadrant. So here both B and B dash, they will be lying above my XY line, and distances will decide which point will be coming above and which point will be coming below. So this we have already discussed. Since the distance above HP is 35, so B dash will appear 35 mm above the XY line, and since the distance behind VP was 25, so this point B will lie 25 mm above the XY reference line, because we have already understood that in the second quadrant both the projections will lie above the XY line. Now point C, it lies in the third quadrant. So the distance behind VP is 25. So we can draw it upwards. Distance below the HP is given to us as 30 millimeters. So we can draw this below the XY line. So in the third quadrant, my front view will lie below the XY line and my top view will lie above the XY line. So this point lies in quadrant number 3. Then for point D, you have got the distance is 35 mm below HP. So D dash will appear 35 mm below HP, and the distance in front of VP is 25 mm. So we get point D 25 mm below the XY reference line. So these are the coordinates of the point D, which is located in quadrant number 4. So all these projections we have drawn 30 mm apart. Then for point E, it was lying in HP, so E dash appears on XY line and it lies 25 mm in front, so it will be coming below the XY line. So this distance is E. So the top view lies 25 mm below the XY line. In which quadrant does it lie? First and fourth. So point F, it is lying on HP, so the front view will lie on my horizontal plane, and since the distance behind VP is 20 mm, so after rotation this will be coming upwards. So point F will lie 20 mm above my XY reference line. And in which quadrant does this point lie? Second and third quadrant. Then my point G, it lies in VP. If it lies in VP, my top view will lie on the XY reference line and it is 15 mm above HP. So my front view will lie 15 mm above the horizontal plane, and the quadrants are first and second for point number G. Similarly for point H, it is lying in HP, so it's lying in VP, so its top view will be lying on the XY reference line, and since this point lies 15 mm below the horizontal plane, so the front view will lie H dash 15 mm below the XY reference line, and the quadrants for this point, they are third and fourth. And finally you have point I. This point I lies both in HP and VP, so obviously both the coordinates, that is I and I dash, they will be coinciding with each other and they will both lie on the XY reference line, and the quadrants for point I, they are 1, 2, 3, 4. So this way you can see, earlier we had discussed all these cases individually. Now parallelly we have drawn all these points onto the same XY reference line. So we need to draw a longer XY line and show the projections of all these points onto my drawing sheet. Now we are going to pick up another question regarding projection of points. So let us find out what are the coordinates of this point in the space. So please read this out. A point P, it is there in the first quadrant, and its shortest distance from the XY line is 60 mm. So its shortest distance from the XY line is 60. So if I draw a string from this XY line junction, that is, and extend this line, so this length of the string will be 60 mm. And second thing, it is given to me that this point happens to be equidistant from the principal plane. It means that its distance from HP and distance from VP, they are same. So if the distances of this point from HP and VP are the same, then obviously we can assume that the angle at which this string is going to be there will be 45 degree, because the string angle from HP will be 45 and string angle from the VP will also be 45. So let us draw this. So we are going to draw a profile plane over here so that we can show this onto the profile plane. So just see, a profile plane we have drawn, and once we draw the profile plane, now I am going to draw this string. So this is my horizontal plane, this is my vertical plane. One string I am going to draw. How much? This string length will be 60 millimeter. And how I am going to control this orientation? Orientation of the string or the line has to be, projection line has to be 45 degree from HP and 45 degree from VP, so that the point P will be equidistant from both HP and VP. Now I have located the coordinates of this point in the space. Now after this, now I am going to look at this point from the front side. Once I look at this point from the front, so this P point will be projected on my vertical plane, because front view is to be obtained on the vertical plane. So this point P will be projected on the vertical plane, and the name of this point will be P dash, because on the vertical plane in the front view, whatever point or projection is obtained, its name is P dash. Similarly, you look at this point P from the top. Now this projector line will be touching my horizontal plane at this position. So once I am looking from the top, the name of the projection will be top view, and it will be represented by small p. Now front view has been obtained, top view of the point has been obtained, but both of these, they are lying in the mutually perpendicular planes. So this will stay, that is the front view which is drawn on vertical plane will stay in its position. And now I am going to rotate my horizontal plane clockwise. So once again, I'll keep my needle of the compass over here, open the compass this much and rotate it downwards below the XY line. This is my XY line. So rotate it downwards till it meets this particular projection downwards. So let us draw this. So please check. 60 mm is the length of the string or my projection line. It is a construction line. And if I am going to talk about the projection of this point, this is my x1, y1, that is, this is the hinge which I am going to open. My profile plane will be opened on this side. Please check this out. This is my vertical plane, this is my horizontal plane, this is my profile plane. So my VP is lying here, my HP is lying here. I have rotated it downwards, and this is my profile plane which has been rotated in this direction. Now if I look at this, this is my profile plane. So projection of the point we have already discussed earlier, which are obtained on the profile plane, will be denoted by P double dash. And now if I look at this from this side, that is front view, this projection will be obtained over here on the vertical plane. So this name is P dash. Similarly, if I look at this object from the top or the point P from the top, I will obtain projection of the top view over here. But this projection of front view and this projection of top view, they are falling in mutually perpendicular planes. So I have to rotate this downwards. So keep the needle of the compass here, open it this much, rotate it downwards. And once you rotate it, this coordinate will be shifted over here. So P point lies here and it lies vertically below the point elevation. So elevation and plan of the point P, they will fall in one vertical line. So now since this angle was 45 degree, so now I am going to measure the distances. So 60 cos 45 and 60 sin 45, they are going to remain the same. So this distance I have measured as 42 mm and this distance I have again measured as 42 mm. So it has proved the point that this is a point which is equidistant from the principal planes of HP and VP. So distance of the point from HP is this much, just see, and the distance of the point from VP is also 42 mm. So these are the projections of the point which was located in a profile plane. So this is another case of the projection of points, and the point was lying in the profile plane that we have picked up. Hope you have understood about the projections of the points which are lying in different orientations depending upon their distances from HP and VP. So these fundamentals we are now going to use while we discuss the projections of the line in the later series.